Hi students, welcome to Max Point of View. Today we are going to solve each and every theory question from the chapter Reflection of Sound Waves and Echoes. This is part A of the main chapter Sound. So before watching this video, my suggestion is watch the concept video first. So most of the questions you will understand it immediately. Or definitely many questions are going to confuse you. The words which we are going to use, those will definitely confuse you. So watch the concept video first and come back to this video after that. So without wasting any time, we'll start with our first question. Our first question, state two factors on which the speed of a wave traveling in a medium depends. So we need to state the factors which will affect the speed, This is very much important. Okay, listen, the two factors are very simple. Elasticity and the second one is density. See, these two are very much important. Why? Because based on this one only the speed of waves are dependent. I'll give you one example. Density. Which is denser, water or gas? Water is denser. That's why the speed of waves in water is greater compared to the gas. So that's why the speed of a wave in a liquid is more compared to the gas. But when you compare the speed of wave in any liquid and solid, the speed of waves are greater in solids. Why? Because they are more denser. So not only the density, it also depends upon the elasticity. See, the elasticity means when you apply a force on an object, it changes its shapes. But when you release the force, it goes back to the same shape. That is nothing but elasticity. More the elasticity, more will be the speed. So it does not only depend upon density, it also depends upon elasticity. Our next question, what are mechanical waves? The waves which require material medium to transfer energy. These kind of waves are called mechanical waves. See, nothing, just to transfer energy. What kind of energy we are transferring? Potential to kinetic or kinetic to potential, vice versa. For this transfer of energy, it requires a medium. Those waves are called mechanical waves. Our next question, define the following terms in relation to a wave. So this question does not require any diagram, but for a understanding purpose, we have drawn the diagram. With the diagram, with the graph, it is easy to understand the concept. So what is amplitude? See, when it comes to amplitude, this is nothing but amplitude. Okay, so how to define it? The maximum displacement of a wave from its rest position or mean position. Next one, the frequency. The number of waves in 1 second. See, there might be many waves in 1 second. How many vibrations? See, this one complete thing is also called as wave. It is also considered as vibration. One vibration is equal to one wave. So sometimes they'll use wave, sometimes they'll use vibration. You should not get confused. So this is one wave is nothing but one vibration. So number of waves in 1 second or number of vibrations per second, that is nothing but frequency. Next, wavelength. The distance traveled by one wave. The distance traveled by one wave, or you can assume it as the length of one wave is called wavelength. So what is the length of this wave? That is nothing but wavelength. Now the final one, wave velocity. So the distance traveled by a wave in 1 second. So how much distance it has traveled in 1 second? That is nothing but wave velocity. Our next question, a wave passes from one medium to another medium. Mention one property of the wave out of speed, frequency or wavelength which changes, which does not change. If you have seen the concept video, this is a very simple question. When it comes to speed, frequency and wavelength, we know frequency does not change. Why? Because keep this mind, in this question they are not asking why, but you should know the reason. Okay, because we don't know what kind of questions they are going to ask. Frequency does not change. Frequency of a sound does not change because frequency of sound depends upon the source. Okay, who is creating the noise? Here I am talking, right? I am the source. So if you are talking about a violin, okay, that violin is creating the sound, so violin is the source. So frequency depends upon the source, does not depends upon the medium. So frequency will never depends upon the medium. That's why it will never change when it moves from one medium to another medium. Air to water, water to air. If the sound travels, it will never, the frequency of the sound will never change. But when it comes to speed and wavelength, okay, these two completely depends upon the medium. That's why it will change. Okay, when it transfer from one medium to another medium, speed and wavelength will change because these two depends upon the medium. Frequency will never change because frequency depends upon the source, not on the medium. Our next question, state two differences between the light and sound wave. See, here they are just asking two differences, but in the concept video we have learned 5 differences. That's why we are going to skip it. And this is a direct question, not a logical question, right? This is not a give reason question. That's why we are going to skip it. Our next question, what do you mean by reflection of sound? We have few more sub questions. We'll go one by one. So first we'll understand what do you mean by reflection of sound. The returning of a sound wave. After striking the surface such as wall or metal sheets. Okay, returning of sound wave after striking the surface back to the same medium. This is nothing but reflection of sound. Next, so it is exactly like a reflection of light. It hits the mirror, okay, then comes back. Okay, this is nothing but reflection of light. In the same way, reflection of sound is also there. Next, state one condition for reflection of sound. See, you have to be very careful whether they are talking about reflection of sound or echo. So for echo, there are many conditions. For reflection of sound, they will have only one condition. So you need to understand the difference between reflection of sound and echo. So both are little different. Okay, but when you have to focus on the word reflection of sound, here we are talking about. So the only condition is the surface, okay, the striking surface has to be bigger compared to the wavelength of the sound. So if you write, okay, in like this, the size of the surface should be greater than the size of the wave. That is completely wrong. Okay, you have to mention the word wavelength of sound. That is very much important. Wavelength of sound is the keyword here. Next, name a device in which reflection of sound wave is used. Megaphone. So in megaphones, this is the megaphone. It's almost like a speaker. Okay, in megaphone we use the concept of reflection of sound. Our next question, what is meant by an echo? The sound heard after the reflection of sound wave from a distinct obstacle such as cliff, mountain and a huge wall after the original sound is ceased. See, very easy way to understand it. Listen, whenever you talk, the sound hits the wall and comes back. This is the original sound. This is nothing but the reflection of sound. After this, a extra sound is heard. That is nothing but echo. Okay, this is how you need to understand. Next, they are asking us to state two conditions. Actually, there are 3 conditions. We'll name all the 3. First one, the distance. The minimum distance should be 17 meters between the source and the obstacles. Okay, 17 meters is the first condition. Second one, the size of the reflector, the striking. So whenever a sound strikes the surface, that is nothing but the reflector. It is reflecting the sound, right? So that is the obstacles are considered here as reflectors. So the size of the reflectors must be bigger compared to the size of the wavelength of the sound. So that is a very simple way. The size of the reflector or the obstacle should be bigger compared to the wavelength of the sound. Our third condition, the intensity. Intensity has to be sufficient. Intensity of the sound should be sufficient. So okay, if you're standing in front of a wall or a mountain, if you whisper, you will not hear any echo. So the intensity is also important. Our next question, a man is standing at a distance of 12 meter from a cliff. Okay, assume there is a cliff and a person is standing 12 meters away from a cliff. Will he be able to hear an echo, clear echo of a sound? Give reason for your answer. That is nothing but justify your answer. See, we know the minimum distance to hear an echo is 17 meters, but what is the distance given? 12 meters. This is very much important, and they're not just asking whether the man be able to hear an echo. That is not the only question. We have to give the reason. That's why we have to prove it. So now listen. So we need to find the time. So here the time is important. We know the speed of a sound wave, that is 340 meter per second. See, most of the time for these kind of questions, speed will be mentioned. Okay, speed will be mentioned. But for this question, speed is not mentioned, so we can take it as 340 meter per second. So sometimes we can take it as 330 or 320, anything is fine. So most of the time they will give the speed. For this question, we can take it as 340. Then distance is given as 12 meter. We need to find the time. Based on the time, we can easily say, okay, whether he is going to hear an echo or not, and why he is not going to hear it or he is not going to hear it. That is based on time. So very simple. So which formula we are going to use? V is equal to velocity is equal to distance by time? No, that is only for when the wave is going. Whenever we are talking about reflection, reflection means it is going and coming back. So 2 times it is covering the distance. So this is what we have learnt in the concept video. V is equal to 2d by t. It is not V is equal to d by t. Okay, it is 2d by t because the sound is going and coming, 2 distances, right? So 2d by t. So t is equal to 2d by v. Substitute all the values. 2 into 12 divided by 340. This will be is equal to 0.07 seconds. So this is what we are going to get. Okay, next, now listen. So we know in the concept video I have taught you the minimum time should be 0.1 second. 0.1 second. That means if the time, okay, the time taken by a sound wave to move forward and come back, it should to hear an echo, the minimum time should be 0.1 second. If it is more than that, if it is more than 0.1 second, you will hear an echo. If it is less than 0.1 second means, so you will not hear an echo. And they are also asking for the reason, because the reflected sound will mixes with the original sound. So there will be no echo in these kind of conditions. So the minimum time should be 0.1 second. If it is less than that, we will not hear an echo. If it is more than that, we can hear an echo. Our next question, state 2 applications of echo. See, there are many applications in the textbook. That is what we have learned from the concept video, correct? More than 5. That's why we are going to skip this one, because there in the concept video I have explained it in depth, and you can easily get the answer from that, and there is no logic behind this question, or it is they are not asking us to define anything. That's why we are going to skip this question. Our next question, explain how the speed of sound can be determined by the method of echo. So how we can calculate the speed of sound using an echo method? It's a very simple question. So you can write it as V is equal to 2d by t. Okay, this is enough. This is sufficient to answer it. But if you want to explain it, very simple. We know whenever we talk about echo, it is nothing but moving a sound from the source, hits the obstacles and returns back to the original position. So it is covering 2 distances, and it will take some time. Take some time. Based on these 2 factors, we can aram se find the value of velocity. Our next question, state the use of echo by a bat, dolphin and fisherman. See, this is nothing but the application of echo. That is why we have skipped one of the questions, right? The same question here in a different way. That's it. So that's why we are going to skip it, because we have learned this one in the concept video. Our next question, how do bats avoid obstacles in their way when in flight? This is nothing but use of echo by a bat. So the same question in a different way. That's why we are going to skip it. Our next question, what is meant by sound ranging and give one use of sound ranging? Very simple. See, sound ranging is a process of finding the obstacles, using the echo. This is nothing but sound ranging. Definition of sound ranging. Give one use of it. The bat, dolphins are using the sound ranging method to find the obstacles or the enemies. Our next question, name the waves used for sound ranging, state one reason for their use, and we have one more question. See, name the waves used for sound ranging, that is nothing but ultrasonic. This is what we have learned from concept video. State one reason for their use. They are not asking just for the use. What is the use? They are asking the reason for their use. That means ultrasonic waves are high frequency. High frequency means it requires less time. Okay, less time to complete the process. This is the main advantage. Okay, main reason. Then why are the waves mentioned by use not audible for us? Because they have high frequency, more frequency than our audible range of frequency. What is that? 20 to 20,000 hertz we can hear, but here when it comes to ultrasonic it is more than 20,000 hertz. That's why we cannot hear it. Our next question, what is sonar? State the principle on which it is based. Very simple. Sonar, what is sonar means they are asking us to expand it. Sound, navigation and ranging. This is sonar. The principle is echo depth sounding. See, you can, instead of writing echo depth sounding, you can explain the whole process. Instead of that, there is a simple name for it. Okay, that is the thing, but echo depth sounding. Our next question, state the use of echo in medical field. See, this question we have learned in depth in the concept video. The same question, there is no change in it. That's why we are going to skip it. Now we have understood all the theory questions from this chapter. Now the remaining thing is numericals. So you have watched the concept video and we have skipped some questions because the same question, the same concept we have learned in concept video without changing anything, like differences, uses, all those things. Only these kind of questions we are going to skip it. The logical questions, definitions, we are not going to skip it. And after this we have some numericals. Solve it, you will learn everything about part A. After that, continue the same method in part B and part C of sound also. Thank you.